Okay, we're going to continue our discussion about the introduction to chemistry and measurement, and this is Unit 1, Lesson 2.1. The lessons do correspond to the sections in the book, so if you're wondering why it's Lesson 2.1 within Unit 1, that's the reason why. Now I might change that as the year goes on so the lessons correspond to the units, but for now we'll leave it at that. So anyway, if you're looking for where this information is located, it would be section 2.1 of your book, which is chapter 2. Alright, so let's take a look at matter and properties. First of all, we want to talk about what matter is, and we've talked about this in a little bit in class, and we defined matter as anything that has mass and takes up volume. So, when we talk about things that are considered matter that do these two things, we're basically talking about the elements that are located on the periodic table. So, there's about 118 of those. 92 of those are naturally occurring elements, but we're only really going to be concerned with maybe 30 or 40 of them. So, when I'm talking about matter in class or on these vodcasts, what I'm referring to is those elements on the periodic table, either by themselves, so like hydrogen. Now we'll talk about why hydrogen is always in the form of H2, but that'll be for later, and how these elements come together to form new compounds. For example, when H and O come together, we're going to form H2O. Now, we're going to talk about how this happens. O is actually in the same form O is actually in the same form O2. So if we just took a hydrogen from the periodic table and an oxygen from the periodic table, we can put them together to form water. We'll talk about these details a little bit later. But anyway, matter can be in two forms. It can be a single element, or it can be multiple elements coming together to form what we're going to refer to as compounds. So down here it says what is not matter, and there are lots of things that are not matter. Ideas, beliefs, ESP, all sorts of things. But for us, we're really going to categorize things into two categories: matter and energy. So throughout the year, we're going to talk about the elements from the periodic table, in other words, matter, but then we're also going to talk about energy. So, when we talk about matter, there's two types of properties that we're going to use to describe matter, or, well, we'll just say to describe matter. We have extensive properties and intensive properties. Extensive properties are properties that depend on how much of the substance you have. So for example, your mass, you could have 5 grams of water, you could have 10 grams of water, you could have 110 grams of water. So that property mass is dependent on how much of the substance is present. So then clearly volume would also be an extensive property. You could have 5 milliliters of water, 10 milliliters of water, etc. So depending on how much is there, that's going to depend, or that's going to dictate that actual property. Intensive properties, on the other hand, do not depend on how much is there. Intensive properties are dependent on what the actual compound is. So for example, water has a property that we refer to as density. Density is going to be equal to the mass of the substance over the volume of the substance, so it's a ratio of mass to volume. But the density of water is 1 gram per milliliter, regardless if you have 5 milliliters, 10 milliliters, 100 milliliters, etc. So regardless of how much water you have, the density is always the same. It's 1 gram per milliliter. So that makes density an intensive property. Solubility is another property that is dependent on the compound itself, or the substance itself. So solubility is basically the ability of something to dissolve in water So regardless if you have 10 grams of the substance or 15 grams of the substance, it either dissolves in water or it doesn't. So, why are these properties important? Well, what we're going to do with properties throughout the year is we're going to identify compounds based on their properties. Mass and volume, extensive properties will be used in the lab to collect data. Oftentimes, though, when we identify compounds based on data, it's usually the intensive property that is going to give us a clue as to what the compound is. So for example, if we're looking at a liquid and we calculate its mass and we calculate its volume or measure those things and we find that its density is 2.3 grams per milliliter, then we certainly know that the substance isn't water. If we had a list of densities and 2.3 grams per milliliter was one of those densities, that would give us a clue as to what that substance is. So, for the rest of the year, as we talk about these substances and we try to identify them, you want to think about their properties in terms of extensive properties and intensive properties.